Hi, I would like to take you through again a quick revision on linear graphs. But I'd like to let you know it is so important to know what is gradient and what's the y-intercept all about. Now a quick revision on it, if you can recall what the gradient is all about. Yes, you got it. It is the point y1 minus y2 over x1 minus x2. If you look at this, all right, you take this as x2, y2, and here is x1, y1. The gradient will be y2 minus y1 over x2 minus x1. Or it could be y1 minus y2 over x1 minus x2. Now it's also crucial that we learned, having found the gradient, we should also find the c. The c is none other than a y-intercept. Now very quickly, let's get through this. If you look at this, how do you find the gradient? It will be 8 minus 4, right? And it will be 4 minus 1. And you will get 4 over 3. This is the gradient. And having got the gradient, to get the equation of the line, we know that y equal to mx plus c. Writing it down, it is always good to write clear steps. Step by step, when you present your answers, your teachers will be most impressed with the way you write the style. Please do not skip your steps. Now you've got your gradient and you want to get the equation of a line. So you have to say with relation to a point, any point, it could be 1, 4 or 4, 8, they would both give you the same c if you refer to the earlier lesson. Now let's take an easier point so that the substitution would make it smooth. At 1, 4. Now at 1, 4, your y is a 4, your x is 1, your gradient is 4 over 3. So we substitute these points and we'll get your c. So what does c become? Yes, 4 wholes minus 4 thirds, and that means 4 wholes minus 1 whole and minus 1 third from it. So you have 2 wholes and 2 thirds. Yes, 2 wholes and 2 thirds, and hence the equation of this line will be equal to y equal to 4 thirds x plus, if you wish to express it as an improper fraction, it will be 2 and 2 thirds is 8 thirds. Can anyone tell me how else can we express it? As I said, you could call this equation in many ways you like. And a general quick revision tells us we can multiply all by 3. So this could be 3y. We could bring 3y equals to 4x plus 8, right? Or you can bring the 8 over 3x minus 8 is 4x, right? Great. Now let's move on from here. And I'm very interested that although we're doing linear law, we would also like to connect it to coordinate geometry. I'd just like to give you a little bit of a head knowledge in it, as coordinate geometry and linear law are interweaved in some ways. We could find a connection, and if you have a little bit of knowledge in coordinate geometry, you flow through with ease in linear law. Now let's look at this point, A and B. What is the distance between A and B? If you look at it carefully, you've got your x is 1 and your x is 4. And if you look at your x, here is 1. I would like to erase this so they can see it more clearly. Alright, let's look at points A and B. And we've got, this is 1, 4 and 4, 8, B. And we want to find the distance. This is 1 and your y is a 4. 4. And your x here is a 4 and your y here is an 8. Now if you would like to find the distance, the x distance and the y distance, let's look at the horizontal distance. From 1 to 4, what do you get? Yes, 3. So the distance between the horizontal distance is 3. And how about the vertical distance? If you look at the vertical distance, this is 4 and this is 8. So 4 to 8 will be 4. Hence, you remember Pythagoras Theorem? When you have a distance of 3 units and 4 units, and if you look at Pythagoras Theorem, and the angle that it make here is 90 degrees, then you get the length here to be equals to 3 squared plus 4 squared square root. You will get 3 squared plus 4 squared, which is 9 plus 16, 25. The square root of 25 is 5. Pythagoras theorem tells us that if this is A, this length is B, and this is C, A squared plus B squared equals to C squared. And this would be very useful to get the length of a line. Now remember, horizontal, vertical, they cut at 90 degrees. And because of that, the 90 degree, you get a right angle triangle. And hence, Pythagoras theorem comes in very handy in getting the length. Now let's translate this vital information into a formula. What is the length of AB? Well, we just learned that it is, you got to find out the distance between 2 points, the horizontal distance, you square it out, and then you find out the distance of the vertical gap, y2 minus y1, square it up, and then add them up and find the square root. Don't you see Pythagoras? A squared plus b squared equals to c squared. The length here is a hypotenuse. The hypotenuse is the longest side of the triangle, and we can see that c squared is equal to a squared plus b squared, and hence c is the square root of a squared plus b squared. Just a similarity, this is your a squared plus your b squared, and you find the square root, the distance between 2 points. Now we move on to here, just a very quick revision again, a very fast one, remembering the length of the line. How do you find the length of PQ? Think through. Aha, you got it. You know that this is 2 minus 2, and the length of this is 3. Right. And if you look at the vertical distance, this is 10 and this is 4. So if I were to draw a right angle triangle, let's do it, class. Yes. Look at this right angle triangle. We want to find the length of PQ, which is from 10 right up to 4. Right? 10 minus the 4, you get a 6 units here. And a minus 2 all the way to 3. What would that be? Look at the absolute value of the horizontal distance. This is 2 units, and that's 3 units. 2 plus 3 is 5 units. So this length is 5. And by right, the length of PQ will be the square of it. 6 squared plus 5 squared. Sum them up and find the square root. So you would get 6 squared plus 5 squared, square root of it, 36 plus 25, you get 61. Right, and so the length of PQ is the square root of 61. Hope you get that length into in, and that would help you get the picture right, linear law and coordinate geometry. When you get to that chapter, the following chapter, you will find coordinate geometry a lot more easier, because linear law is going to help you to get this picture right too. Now let's look on and move on, alright? But a very quick revision before we get on. The length of a line, AB, as I would like to emphasize, is the distance between the 2 points, the horizontal distance, which is x2 or x1. If you started with x1, then you put x1 minus x2 squared. And here again, what do you write? Do you put y2? No, y1, because we started with x1. So it will be y1 minus y2 squared. And the square root of it, right? So here we see, don't you see the connection? Linear, Pythagoras, and coordinate geometry. They all are in sync. The theories flow. Now, how about the midpoint? A quick revision again. A midpoint will be the sum of the distance x1 plus x2 divided by over 2. Is an average. And here, a y1 plus a y2 divided by 2. If you look at PQ, alright? If you look at PQ, P is minus 2 and 10. That's your P. And your Q is 3 and 4. And so the midpoint of P and Q would be, yes, let's call it M. It is minus 2 plus 3 divided by 2. The x1 plus the x2 divided by 2. And here we get 10 plus 4 divided by 2. So your midpoint will be 1 upon 2, yes, half, and 14 upon 2, 7. So this will be a point that you could mark on your linear graph. There are questions sometimes asking you, determine the midpoint of AB.